Okay, B-2. B-2 says a 30-kilogram shopping cart full of groceries sitting at the top of a 2-meter hill begins to roll until it hits a stump at the bottom of the hill. Upon impact, a 0.25 kilogram can of peaches flies horizontally out of the shopping cart and hits a parked car with an average force of 490 newtons. How deep a dent is made in the car? Okay, so the amount of information given is a little misleading, but it's still okay. It makes you differentiate between the information that is given that is good and the information that is given that is not particularly necessary. It's a 30-kilogram shopping cart. It's on a hill that's 2 meters tall. Okay, now, the amount of potential energy that that shopping cart has is quite a bit. It's 30, it's mgh, 30 times 2 times 10, which is G, so mgh. So G is 10 and H is 2. However, the shopping cart doesn't hit the car, the can of peaches does. The can of peaches does. How much potential energy is that can of peaches going to have that's in the shopping cart? Well, it's going to have mgh. It's going to have a mass of 0.25 kilogram, newton, meters, kilogram. So you're okay to use no unit labels. We know that that 0.25 is kilograms, okay? 10, and then H is 2. Okay, easy? So 0.25 times 10 times 2 is the potential energy that the can of peaches has at the top of the hill. Okay? It's going to go down, hit that stump, and it's going to have a kinetic energy that is born out of a kinetic energy that's born out of the potential energy that it had at the top of the hill. So that potential energy is going to be converted to kinetic energy. So I can say that that energy is the same as the kinetic energy that it has at the bottom of the hill, and that's going to be equal to the 490 newtons that that can hit that car with, and times the depth of the dent. So 0.25 times 10 times 2 divided by 490, and that dent, if you calculate that out, will be 0.01 meters. And that's 1 centimeter. If you own that car, that's a pretty significant dent. Okay? That's it. B2. Okay? All right.